Hello everyone, I'm Yaru. Today I'm glad to present goal sampling adaptation for scooping with curriculum reinforcement learning. Scooping is an instinctive skill for human beings, and we apply scooping in different aspects. Can robots also do that? Some works have explored robotic scooping, while they mainly focus on scooping solid materials instead of deformable objects or liquids. In fact, water or liquid scooping can be helpful to a lot of downstream tasks which might require a specific amount of liquid to be poured or transported. So how to achieve goal condition water scooping? Prior works on goal condition deformable object manipulation mainly focused on cable, fabrics, or bags, and often rely on heuristics, action primitives, or demonstrations, which might be infeasible for goal condition water scooping. In this work, we aim to achieve robotic water scooping with specific water amounts and targeted positions in different conditions, and formulate the problem using goal condition curriculum reinforcement learning. To design the curriculum, we propose factorized goal sampling adaptation. We first consider the position goals. For example, we have a desired position goal distribution which is high in the air above the water tank, and directly training to achieve those goals can be difficult. So we'll first pick an initial position goal distribution near the water, which is relatively easy to reach. Then during training, we'll gradually interpolate intermediate position goal distributions between the initial and the desired. In this manner, the container can learn to achieve the challenging goals with the curriculum. For the amount goal sampling adaptation, directly reaching the targeted position without scooping water is easy, so there is a high probability within the initial amount goal distribution to scoop no water, so that the container can first learn motion primitives to reach different targets. After that, we gradually increase the probability to sample the real desired water amount goals. We achieved promising results in both simulation and real robot scooping. Please check out our paper and website for more details. Thank you.